Welcome back. We're going to keep this thing rolling and we're still reviewing. I'm still Mr. Cortez. Mr. Cortez works just fine. Mr. Cortez lives in South Philly. Did you know that? Ever been there near the stadiums? We're reviewing exponential functions and a quick recap on that. You have seen exponential functions since integrated one, my friend. Equations might have looked like this if you knew that you had some starting amount, usually at f of 0 or where x equals 0. You had your b here, which was your common ratio, which was pretty cool. It's pretty much saying, what are you multiplying by over and over? This is pretty helpful. And then you would say that that happened x times in comparison to a linear line. This one curved like so. Start small and big, or potentially start big and small. Actually, no, it wouldn't even look like that. That looks insane. No, sometimes it would just look super big and then go down super small. There you go. You might have also seen some equations written like so. A times something in parentheses, but then x minus 1. And you use this x minus 1 if you're dealing with usually day one. Like I know in integrated one, I said it was a day one type of problem. So you have to give respect to that and say you're 1 unit away from day 0. This is going to come back again. So just be on the lookout for it. You may want to take a minute to pause the video, take a gander at this, make sure that part makes sense before we start to hop into reviewing today. Okay, let's get to it. Hopefully you're feeling good about this. Mr. Presser, hey, I know that guy. He owns 3 rabbits. I don't know if that's true. Every month, the number of rabbits double. Well, when you hear double, what comes to mind? Times 2 comes to mind for me. Double, double. Let x be the number of months and f of x be the number of rabbits. If I forget, I'll write it down here that this is our number of rabbits. X is our number of months. It's good to keep track of time. Where would you be without a calendar? So you have a number of months. We know that we already own 3, and every month that's going to double. And that sounds like a nightmare. So every time we move forward 1 month, it's going to double the previous amount. So notice we added 1 month. The number of rabbits is going to double. So 3 times 2 gets you 6. Keep it going. 6 times 2 gets you 12. 12 times 2 gets you 24. And then take it to the limit. It's 2 less than 50, so it's 48. And notice this was a nice table. It's not always going to be nice. You will not always be increasing by a consistent amount for x. But in this case, we lucked out. What a privilege for us. Okay, I'm going to do my best to use a lot of this graph right here. Hope that's okay with you. Gonna have x here. Gonna have f of x up here for the number of rabbits. What do you think a good starting amount would be? And what increment would you go in personally? So if it was me, I would do my best to show that this is going to be going up real quick. So I would do something like this. I would say that every increment on f of x is 3. So 3, 6, 9, 12. And that keeps going from there. 15, 18, 21, 24. That's how I would personally do this. And I'm going to go in increments of 1 month for every 2 little blocks. Probably won't be able to fit everything here, but that's cool. We already marked off some of this. We said that at 1 month, it's going to be 6. So we're moving on up. Remember, this is going in increments of 3. So be careful there. And maybe you know what? I'll be nice. Say that for this f of x bit, each block equals plus 3 rabbits. Because I'm not going to write in every number there. I'm going to leave that up to you if you're feeling so inclined. But really, I'm just going to highlight on the key ingredients that we need for this. So let's keep this going. At 3 months, it's 24. And then what is this? This is 8. So if I just want to double that, I need to have 8 increments again. 2, 3, 4. Hopefully this is it. Is that it? 2, 4, 6, 8. Yeah, that's good. Cool. So this is hour 4. What do you think? Would it be smart to go back in time to where x is -1? I don't know. Yo, that sounds pretty crazy. Because if you went back in time, can you really have fractions of a rabbit? Are you saying that in the previous month it was 1.5 rabbits? I'll leave that up to you to discuss. What could you say about the pattern? You could say starting at 3, you could say double. You could be sly with it if you know what that means if something doubles. But if you don't, you could also say we multiply by 2 x times. Do you know the equation for this? Do you remember? It's a little bonus. You could say that starting at 3, you keep multiplying by 2 x times. Or if you're feeling crazy, this is, a day 0 problem or month 0 problem. You could also say something like this. You could say starting at 6, you keep multiplying by 2, x minus 1 times. Both of those are fair game. Take a moment, pause, reflect on this. Does it make sense? Is there a place where I lost you? You can make a note of it. You could let me know in class before we hit the next example. Don't be afraid to do that. Reflect on your learning while you're here. Hey, let's just look at a new example. Let's do it. Tina's grandmother gave her $2 on the day she was born, year 0. Interesting way to denote time. Ever since, this is a typo, I didn't make this. Ever since she has tripled the amount of money that she gives, Tina, let x be the number of years and f of x be the money. Let's say hopefully it's the amount of money that's just given that year. It's not going to like accumulate. So, well, or no. Maybe we'll see how this one progresses. I don't want to say too much. So we have $2 on the day she was born. F of x denotes the amount of money. And x is the amount of years. And every time this triples, so times 3. So this is now 6, 18, 54, I hope. And then, take it one more time. 150, and you add on 12, so 162. There you go. Let's sketch this thing. Some fun facts. Mr. Cortez grew up in Havertown. I guess that's a cool fun fact. Near the YMCA. Parents are still there. And let's jump back to this. So we're graphing this out. X is the number of years. F of x is the amount of money Tina's going to get. So this is going to be interesting to scale. Let's do every tick mark is going to be 2. So let's have this be 2. This will eventually be 6. And let's just keep that going. Just like a little bit more, I don't want to dwell on it. That would be 12, then 18. Okay, I think we'll be all right. So year 0, we're getting $2. That's cool. Then we're going to 6. Again, I'm jumping in for every 2 blocks on the x-axis. That's going to measure 1 year. And I don't have too much more room for other points, but let's just say that it keeps going like that. How can we describe this? Starting at 2, we multiply by 3 x times. That is an okay way to describe this. It's not bad. The graph could be improved, but if you want to scale it up more, if you want to scale it in a different fashion, you are more than welcome to. But for now, I'm going to keep it as is. So I hope that's all right with you. Create an equation. I'm going to do both. Again, in the previous video, we saw that recursive needs two things. You need to know where you're starting, your zero term, and also figure out how it's going to continue. And you're probably going to use f of x minus 1 to denote your previous term. The explicit, we said at the beginning of the video, you start with some increment, you multiply by something, say it's x times. So this should not be too bad. When we already kind of put the phrasing of it together in words, the words are huge. So let's say that for the recursive, we are starting at year 0 with $2. Tina's such a lucky person. And then we keep taking our previous and we just keep multiplying by 3. So that's our recursive. And then for the explicit, you could say starting at 2, keep multiplying by 3, x times. If you're feeling crazy, you could then hop to year 1 where there's $6 and you're still multiplying by 3, but now it's x minus 1 times. And you know what? I'm feeling crazy, so let's do it. Starting at 18, you could say you keep multiplying by 3, but x minus 2 times. These are all legit ways to write how this is going to continue. These are all legit ways to write an explicit form of this pattern. And let's hop into what's going to happen on the 10th birthday. Well, the 10th birthday, that's 10 years away from her birth. So you could throw in an equation like this and take a moment, use your calculator. What is this going to get you? Take a moment. So I bet some of you are probably going to type in 6 to the 10th power, which is a little absurd because you're really taking 2 increments of 3 to the 10th. And 3 to the 10th is just 59,049. And you start to be a little envious of Tina at this point because her grandmother's really stacking the cards in her favor with this deal. And then if you do 2 times that, Madon, Tina is going to walk away with 118,098 cents on her 10th birthday. So I don't know, maybe Tina got in on crypto early in the pandemic or when it was just kicking off. What a privilege that would be. How did we get this answer? We used the explicit equation and just plugged in because I'm sure some of you thought you were just going to keep tripling the number over and over and over, which, hey, if you want to do that just to feel more convinced that this answer is going to work, go for it. But I would rather be over here using an explicit form of this. But if you decided that you wanted to keep running the recursive and multiplying by 3, probably took you a bit more time and you might have made a blooper at some point. But this is definitely how much Tina gonna get. So in recap, exponential, it's curves, it's not a straight line. The equations look like this. It's a little bit more complex and feel a little envious of Tina's grandmother and the situation Tina has because Tina's grandmother, I guess, has the money and Tina's going to get it. So I hope that this video was helpful. If you're stuck on anything, reach out. Thank you for watching.